Hi, welcome to a not very pleasant topic of the data deduplication, which is a part of data cleansing, which is a part of making our data much better for downstream consumers. To start, when you hope that you will implement an exactly once delivery, well, know only that it will be very challenging because there is multiple places where the data can be duplicated, you may have retries, and even though you succeed somehow to deliver only one piece of data each time, there is nothing guarantees you that the downstream consumers will not introduce duplicates. So it's quite a challenge, but as a best effort in our data cleansing pipelines, we should always try to make the data better and eliminate duplicates if they are very problematic or if pragmatically you know that you will have them a lot. So to start, why can you have some duplicates? First, when in the microbatch processing, there is one global transaction, meaning that it succeeds only when all the tasks succeeds. But the tasks are independent because there is no internal coordination mechanism unless you implement it, and they may succeed and retry as they want. So give me an example. You have 10 tasks and the first 5 succeeded, the 5 last failed. And you define the retry numbers for your job for the microbatch to 2. And of course, if you relaunch the microbatch, the first 5 will be retried, and obviously you will need to duplicate if you don't have a way to deduplicate them, say, in the processing. The second reason is related to the previous one, is the at least once processing, meaning that in order to be efficient, you will probably need to be lazy, and the retries are one of the things where the laziness can help, because when there is a temporary failure, the task will retry automatically, and here also when you retry, you will process and deliver data at least once. And finally, there is some bugs. Nothing guarantees that the producers will deliver exactly one occurrence of each record. They may also do some retries. You may also have two different producers generating the same data, so there is always a risk on their side too. And the next questions you should ask yourself is that bad? So sometimes having duplicates is acceptable because downstream consumers may ignore them or somehow smartly work around the issue, but generally it's bad for various reasons. So first, you will have much volume to process. Second, your consumers will need to implement the deduplication logic or maybe share it from some shared dependency. So there is another reason. Third reason is that each record must be identifiable by them, and maybe the identification is not the same. So one duplicate record in the pipeline A doesn't necessarily mean duplicate record in the pipeline B, so there is some consistency risk, and generally reducing these duplicates amount of data is nice thing to do for all your downstream consumers. And there are different strategies to deal with duplicates: the deduplication, transaction, storage idempotency, and probabilistic data structures. So let me focus on each of them in the following slides. So the deduplication relies on some storage that is either external or internal to the processing. So whenever we receive the data, we verify whether the given key is present in our deduplication storage, and if not, we update the duplication storage and submit the data to the sink. Again, when we have another record, we do the same, and when we encounter some duplicate, of course, we will ignore this record. However, there is some problems because keys here must be idempotent, so meaning that if you use some processing time or some undeterministic values, you will not be able to implement this logic. And it's also approximate, because very often to limit some space in this storage, either from the memory standpoint or either from the lookup time, this will be limited in time, so you will have only a limited deduplication window. And there is also another drawback if you do it as a part of and there is also another drawback that I didn't put here, is that at least once, because, or at most once, depending on when you write the data to the key, because when you first write data to the key storage and the data processing doesn't succeed to deliver the record, well, it's at most once processing because you will lose it. And on the other hand, when you first write the data to the sink and later to the key, again, it's at least once, because the key will not be stored in the first run, maybe in a second it will be there. Hopefully, most of the time this solution will work just fine, and you will not have suffered from this two-phase commit. As an alternative, there is a probabilistic data structure called Bloom filters. So these Bloom filters are probably more memory efficient because they generate a hash of 0-1 values in the filter and later apply some hashing function on the key and verifies whether the hash value is present or not by looking for the 0-1s in the filter. So again, our example, and here we can see already that the hash changed for these two specific values, so here and here, and we consider that the key is present. So as I said, it's memory efficient, there is only zeros and one stored, but it can have some false positives and also have some memory impact, because much more memory you allocate to the filter, of course, much more precise it will be. And there is also a challenge with the default implementation that is not adapted to the unbound data, which typically is the case for streaming data sources. And there is also transactions. So transactions, you saw it already also in the course before with delivery semantics lessons, but just to recall that it's a way to ensure that the data is visible to the end users only in the end of the commit action. So here, even though we retwrite the data writing, if the consumer is transaction aware, so it will not consume this data because the consumer doesn't simply see this transaction to commit. And again, there is some pros and cons. First, it may not be available for all databases or streaming brokers, and the consumer also can introduce some duplicates if it doesn't implement the exactly once transactions too. And there is also a way to avoid to skip these transactions overhead by using the transaction non-aware consumers. And finally, there is the storage idempotency, meaning that your data processing job can write data to some, for example, key value store, and here it's a natural guarantee provided by your data store that whenever you use the same key twice, it will always write the record only once. Again, the key must be idempotent, and one interesting part for that is how do you notify the customers about the changes, because you can imagine that the key changed but the value was different, and your customers may want to reprocess data in that scenario. It's much more easier to do in the previous examples, either with the transactions, because simply it will mean to relaunch the consumer and open a new transaction, or the first scenario I detailed was about the deduplication store. Remember, it's very often bounded to time or to memory size, so obviously if you clean up the buffer, you will be able to ingest the data again. So this data deduplication is another example of there is no one magic solution for all the problems. Depending on your team capacity, depending on your previous experiences, you may want to implement easier or much more challenging solution. Thanks for watching, and see you in the next lesson.